Okay, question 21. Now we have an unknown metal with a mass of 23.6 grams. So we have a mass. It's unknown what it is, right? But we do weigh it, and it's 23.6 grams. And it's placed in a graduated cylinder. So I have a cylinder filled with water, I assume. Well, there's my water level, right? And that water level says it is 22.0 milliliters. Now I drop this down into my cylinder, boom, sits down the bottom, and that displaces the water. It makes it rise to a new level, and that new level is 30.7, and that's milliliters. Now the cause of that change is due to the volume occupied by that unknown metal. So we take 30.7, subtract 22, so it is 7, and 8.7 milliliters is the volume of that unoccupied. So what we just have to do to calculate the density is take 23.6 grams, divide that by 8.7 milliliters, and the answer that I come to here is 2.71 grams per milliliter. That's the density. And then I look among my list to identify the metal, and that appears to be aluminum, 2.7. Very close. Again, these are measurements, so there's going to be error. There actually is only 2 significant digits here in this right answer because that's 8.7. So when I do that, that goes away, and 2.7 matches 2.70. So aluminum would be my correct answer. Now, question 23 is actually fairly straightforward. I have a solution, so I'm going to have a amount of water here, and I have 2.50 liters, which means I have 2,500 milliliters if I do the unit version, or if I just know I move my decimal 3 places to go from liters to milliliters. That's how much is in there, and because the density is 1 gram per milliliter, that means I have the same number of grams. If it's 1 gram for every 1 milliliter, 2,500 grams are in that solution. But then what I do is I take and add to that 250 grams of KOH. That goes down in here. And so now I have the 2,500 grams from the water plus the 250 grams from the KOH. That's my total. So my total mass then is going to be 2,750 grams, and the amount that comes from the KOH is 250 grams. So that's my mass over mass. This question is in percent by mass, so I have to multiply that by 100%. Grams are going to cancel, and I'm left with my percent here for my answer. And so my answer, represented to the right number of significant figures, then is going to be 9.09%. Well, the only place you're going to get tricked up here is that you got to remember, you won't be able to see that KOH, potassium hydroxide. It dissolves. It's a homogeneous solution. We talked about that in class today. But the total mass, so if this were all sitting on a balance, as I add the 250 grams to the 2,500 grams that are already there, it will show up. It doesn't disappear. Mass is conserved, so the total mass has to be counted. Question 23 is a very straightforward question. The process by which gas condenses is referred to. So I've got a gas that will become a liquid. It's condensing. That's the opposite of when we take a liquid and turn it into a gas. Now just think of water on a stove. If you've got liquid water and you want to turn it into gas, you have to raise the temperature, so you have to add heat, right? You have to add, that would be an exothermic. That's going in the other direction. Now, to make a liquid at 105 degrees Celsius, cool it down to 95 degrees Celsius so the gas becomes the liquid, you have to extract heat, and that is an endothermic process. Heat has to be removed. Oh, I'm sorry, I am backwards. Endothermic is when you add the heat. Backwards, and you make the gas. To extract it, you have to pull it out, and that makes the process exothermic. Not the right answer, exothermic. You have to remove heat, exothermic.